Free body diagram. Imagine you're a detective investigating a crime scene and you need to figure out what happened. But how do you do that? You start by looking at the clues, the evidence, and the forces at play. That's exactly what a free body diagram does for physics problems. Think of it as a detective's sketch of forces acting on an object. We isolate the object like a suspect in a crime and draw arrows representing all the forces affecting it. In physics and engineering, a free body diagram, also called a force diagram, is a graphical illustration used to visualize the applied forces, moments, and resulting reactions on a body in a given condition. For example, imagine a book sitting on a table. What forces are acting on it? Gravity pulls it down, the table pushes it up, and maybe even a little bit of friction from the table's surface. So these are the forces we draw on a free body diagram. Why is this important? Because it helps us understand what's happening to the object. We can see if the forces are balanced or not, if the object is moving or staying still. This helps us solve problems and predict how things will behave. Let's say you want to know how much force is needed to push a box across the floor. Without a free body diagram, you might miss some important forces like friction, but with a free body diagram, you can clearly see all the forces acting on a box and calculate the force needed to overcome them. Free body diagrams are used in many areas, from designing bridges and buildings to understanding how rockets launch into space. They help engineers and scientists understand how forces interact in the real world. So next time you face a tricky physics problem, remember the detective's secret weapon, the free body diagram. It's your key to unlocking the mysteries of motion and forces. In the upcoming videos, we will learn how to draw the free body diagram of different objects.